Okay, back again. So we're starting with number 20 from test 2, Math 107. So the question is, again, two versions of the question. Decide whether the following is a probability distribution. If it is not a probability distribution, identify the property or properties that are not satisfied. So in a probability distribution, you have the values of x, discrete random variable, whole numbers like 0, 1, 2, 3, 4, and then the associated probabilities. So for it to be a correctly made probability distribution, two things have to be true. Each probability has to be between 0 and 1 inclusive, because 0 means something is impossible, an event, that could be probability. 1 means it's certain to occur, that could be probability. It's usually something in between. So in the one version of this question, we have that it is the correct answer so the probability of 0, let me write it out here. 0 was 0.02, probability of 1 is 0.40, probability of 2 is 0.38, 38 hundredths, probability of 3, 19 hundredths, and the probability of 4 is 3 hundredths. And so the correct answer is it is not a probability distribution, because if you add these up, let me do this quickly. These probabilities, they add up to 1.02, and the sum should be exactly 1. So that's the correct answer. The two incorrect choices for that is that it is a probability distribution, or the other incorrect choice is that it's not a probability distribution because a probability cannot be 0.40, but a probability could be 0.40. That's fine. So the correct answer for this one is that it is not a probability distribution because the sum is not 1. The other version of question 20, let me write out the table. Again, you have discrete numbers 0, 1, 2, 3, 4 for x. You have the associated probabilities 0.02, 0.40, 0.38, 0.25, and negative 0.05. So that's the problem right there. This probability of negative 0.05, that cannot be a probability. Probabilities cannot be more than 1 or less than 0. So the correct answer is no, because the probability of x cannot be equal to negative 0.05. The smallest probability you can have is 0. One of the possible answers, which was not correct, is that the sum of the probabilities are not equal to 1. They actually are equal to 1 if you add them up, but the problem is not that. It's because you have a probability that's illegal at negative 0.05. And the other incorrect answer for number 20 is that it is a probability distribution, which it's not. So going on to number 21. Question 21 says, construct a discrete probability distribution. Okay. And I really wanted you all to graph it. So I'm going to show you the graph, even though I didn't ask you that, but I could not figure out how to do that. So if I'm constructing my probability distribution here, and let me start with the original one. So we had children and households. So one of the choices, you have 0 children, 210 households, 1 child in 120 households, 2 children in 85 households, 3 children in 55 households, 4 children in 20 households, 5 children in, 10 households. And so what we have to do is we have to add up the total number of households, adding up all those frequencies, and that gives you a total of 500 households. So in order to construct that probability distribution over here, you're going to have 0, 1, 2, 3, 4, 5. Remember, in a probability distribution, you have values of x and their associated probabilities, empirical probability. So 210 households out of 500. So if I go to my calculator and divide that out, I get 0.42. 120 households out of 500 had one child, so that's going to be 0.24. 85 households out of 500 had two children, so that's going to be 0.17. 55 households out of 500 had three children, which is going to be 0.11. 20 households out of 500 had four children, so that's going to be 0.04. And 10 households out of 500 had five children, which is going to give you 0.02. So there's your correct probability distribution. The other one was similar to the review sheet. In the review sheet, the total number of households was 1,000. So really all you had to do was move the decimal point. So the incorrect answer really made this 0.210, 0.120 and all that, but that's not right because you have to divide by 500, which changes it to these probabilities. So just because I couldn't figure out how to do a graph here, but I just want to review that with you in case I can figure that out. So if we were to make this graph a modified histogram, so X is the number of children. Of course, we always want to label our axes. Y is probability. And the highest probability here was 0.42 or about 42%. So I could count by 10%. Everything's better with graph paper, of course, as I always say. So I'm going to draw the bar to the height of the probability. The bars are touching, so the probability of 0 children is 0.42, a little bit more than 40%. Probability of one child, 24%. Probability of two children, 17%. Probability of three children, 11%. Four children had a probability of 4%, and five children had a probability of 2%. So it would look something like that. Of course, the bars should be about the same width here. The other version of number 21 had this table. So we had children, households, so we had 0, 1, 2, 3, 4, 5 children. And the households that match that one are 300, 210, 150, 70, 50, and 20. And again, we need to total the number of households to get our empirical probability. So I'm adding those numbers up in the second column for the number of households, which adds up to 800 in this town. So in order to make our probability distribution of 0, 1, 2, 3, 4, and 5 children, empirical probability here, probability of 0 children would be 300 divided by 800, 0.375. Probability of one child, 210 divided by 800. So rounding to 3 decimal places, you're going to get 0.263. The probability of 2 children, 150 divided by 800. Uh, 0.1875, so about 0.188. Probability of 3 children, 70 over 800. So 0.0875, so about 0.088. Probability of 4 children, 50 divided by 800. 0.0625, so 0.063 approximately, rounding to 3 decimal places, and probability of 5 children, 20 over 800. 0.025. This might not add up to exactly 1 with the decimals, but it would with the fractions. And so that was your choice. And again, the incorrect answer was to just move your decimal place over 3 places like it was in the review sheet, but that was only because we were dividing by 1,000 again. You have to divide by 800 here. All right, so question 22. From past records, a teacher finds that 25% of her students attend tutoring sessions. She checks the records of 6 students to see if they attend tutoring sessions. The random variable represents the number of students who attend in tutoring sessions. Identify a success and a failure. So a success is what the random variable counts. Someone attends tutoring. As a teacher, I also think is a success. As a failure would be the complement. Someone does not attend tutoring. And I think there were just really 2 choices, a multiple choice on that one. The other version of question 22 says, from past records, a doctor finds that 30% of his patients have no insurance. My coworkers are making noise here. And so 30% have no insurance. During a 2-hour period, one day he sees 5 patients. The random variable represents the number of people who have no insurance. Identify a success and a failure. So a success is that someone, how it's defined in the problem, has no insurance. I know that's not a success in life, but that's how the problem defines it. A failure would be the complement that someone has insurance. Again, it's however the problem defines a success, whatever X counts. Excuse me, coworkers, can you be a little more quiet? Thank you. Okay, so going on to question number 23. One version says, it's the doctor question again, 30% have no insurance of the patients. During a 2-hour period, he sees 5 patients. The random variable represents the number of people who have no insurance. Identify N, P, Q, and the possible values of X. Okay, so N is the number of trials, 5. P is the probability of success, that someone has no insurance. Again, not a success in life, but that's a success in the problem, so that's 0.30. Q is the probability of failure, that someone has insurance. So that is 1 minus 0.30, which is 0.7 or 0.70, because P plus Q, success and failure, probabilities have to add up to 1. They're complementary events. And the possible values of X, the possible numbers of successes is from 0, 0 up to 5. So that's the correct choice. There are other choices which are not correct. Okay, let me try to finish this one before I run out of time. All right, so the other version of number 23, 25% of the teacher's students attend tutoring. Oh dear. Now my timer's going off on my stove. 1 second. Back again. Okay, my coworker set the timer. Okay, so again, she checks the records of 6 students to see if they attended tutoring, which is what's considered a success. Identify N, P, Q, and the possible values of X. So N is the number of trials, 6. P is the probability of success, 0.25. Q, probability of failure, 1 minus 0.25, which is 0.75, because I have to add up to 1. Probability of success, P, and failure, Q. And the possible number of successes and 6 trials is from 0 to 6.